right, well, welcome everyone to the June edition of the Roundabout. I hope you've all had a great spring and got just the right amount of rain for your area. I want to wish all the fathers a happy Father's Day. Next up, of course, is the heat of summer. Stay cool. That's my first safety message of the day, but it's not the last, since today's topic is proven safety countermeasures. Let's get started. So these safety countermeasures have been identified by the Federal Highway Administration, the FHWA, as having unquestionable safety benefits. They've been used enough that we know that the risk of roadway fatalities and serious injuries can be reduced if these items are incorporated into your construction or maintenance plans. Of course, not every countermeasure will be appropriate for every situation, though as a group, they will cover nearly every roadway situation. You will need to determine which countermeasures are most appropriate for your agency to use. There are 28 in all. People admitted here. Kind of doing a little double duty today. Kara Cox, who normally runs this along in the background along with me, is doing another meeting, so I'm trying to let people in at the same time as doing the presentation. So just bear with me, we'll get through it. Let's see what's next. Okay, so here are the proven safety countermeasures. I'm going to cover most of them today, but here's a snapshot of all of them. As you can see, they've been grouped into 5 categories. So there's speed management, which includes speed safety cameras, variable speed limits, and appropriate speed limits for all road users. There is roadway departure countermeasures, which includes wider edge lines, enhanced delineation for horizontal curves, longitudinal rumble strips and stripes on 2-lane roads, safety edge, roadside design improvements at curves, and median barriers. Then for intersections, we have backplates with retroreflective borders, corridor access management, dedicated left and right turn lanes at intersections, reduced left turn conflict intersections, roundabouts, the systemic application of multiple low-cost countermeasures at stop-controlled intersections, and yellow change intervals. For pedestrians and bicycles, there are crosswalk visibility enhancements, bicycle lanes, rectangular rapid flashing beacons, leading pedestrian interval, medians and pedestrian refuge islands at urban and suburban areas, pedestrian hybrid beacons, road diets and walkways, and finally, cross-cutting strategies that can apply to more than one of the other categories. And those include pavement friction management, lighting, local road safety plans, and road safety audits. So for each countermeasure, there's a fact sheet that highlights safety benefits and further describes the countermeasure. The fact sheets are useful for presenting to the public or elected officials when trying to gain support for implementation. In the case of yellow change intervals, there's a reference to the manual and uniform traffic control devices for basic requirements and recommendations about yellow change interval timing. The biggest safety benefit here is a reduction in red light running because drivers are given time to come to a stop. All signals should have yellow change intervals, but especially if you're noticing an increase in red light running, you should review timings to ensure they are appropriate for current vehicle speeds. As I go through each slide, please don't hesitate to unmute with any comments or questions along the way. If you'd rather use the chat, that's perfectly fine too. Just whatever you're more comfortable with. So next up is the rectangular rapid flashing beacon. This may be my favorite, mainly because of this highlighted safety benefit, up to a 98% motorist yielding rate. That means drivers actually stopping for people in the crossing. They can also reduce pedestrian crashes by up to 47%. First, let me make sure you understand what we're talking about here. A rectangular rapid flashing beacon, an RRFB, that's this right here in the middle. I assume you can see my arrow. So the RRFB is added to a crossing warning sign assembly between the main sign and the arrow. This picture shows a trail crossing for both pedestrians and bicyclists, but they are most often used just at pedestrian crossings. So what makes them so special? When someone walking, biking, or rolling intends to cross the street, they push the button and the RRFB begins flashing. This brings the motorist's attention to the person wanting to cross. It's not that someone is just waiting near the roadway. They intend to cross, or they wouldn't have pushed the button. The beacon is timed to flash for the amount of time a typical pedestrian would need to cross the road. But if a pedestrian needs more or less time, the driver can either wait or continue as necessary. It's bringing attention to the pedestrian crossing, not saying you must stop for a certain period of time. Many RRFBs are powered by a solar panel at the top of the assembly. I'm not sure this one is, but the good thing with that is that it can be used in many situations. Any thoughts? Okay. Move on. So the safety edge is a low-cost way to eliminate the potential for a vertical drop-off at the pavement edge. I've heard of numerous fatal crashes in Kansas recently where, for an unknown reason, probably inattention of some sort, a vehicle left the roadway on the right and attempted to re-enter the roadway and lost control. Often that means they go off the road on the other side of the roadway and their vehicle often rolls. In one of the more recent crashes, the driver didn't get to the other side of the roadway and instead struck an oncoming vehicle head on. Very sad. So here's the details of the safety edge. When you're either overlaying or as part of new construction or possibly even as a separate project, a wedge of pavement, this little triangle here, at a 30-degree angle is placed adjacent to the existing pavement. Then the shoulder is brought up to the level of the new pavement. This is critical in and of itself. The safety edge is there as a backup for if and when the shoulder settles or is eroded. With a benefit cost ratio of 700 to 1 or more, it shows up to 1,500 to 1, it seems like a no-brainer to incorporate, especially if you're overlaying a roadway. So 700 to 1 means that if you spend, say, $1,000 on the countermeasure, you could see $700,000 in reduced crash costs. 1,500 to 1, which is probably more likely if you're just adding it to some existing work, because then you're really only adding a small amount of material there. So 1,500 to 1, if you're spending $1,000, would be $1.5 million benefit in crash costs just for $1,000 worth of material. If you were using $2,000 worth of material, that could lead to $3 million in safety benefits. Just interesting. I got a thing that says, confirm that you're speaking in English. I am. If it sounds like gibberish, let me know. All right. So for the next 10 countermeasures, I'm going to focus on crash reductions. Starting with this one at 53% reduction on up to the highest reductions of up to an 89% reduction in crashes. So the countermeasure here is bicycle lanes in general. So the safety benefits start at 30% for urban 2-lane collectors and local roads, but for converting traditional bicycle lanes to separated bicycle lanes, there can be up to a 53% reduction in bicycle vehicle crashes. In this picture from Washington, D.C., there are pavement markings and flexible delineators separating the bicycle lane from the motorist's through lane. Next up, at a 55% reduction in pedestrian crashes are pedestrian hybrid beacons, abbreviated PHBs, but also sometimes called a HAWK signal, when HAWK stands for High Intensity Activated Crosswalk Beacon. It's an intermediate strategy between a flashing beacon and a full pedestrian signal. I've got 2 extra pictures for this one. So here's an actual picture. As you can see, it's mounted on a mast arm over the lanes of traffic, which of course improves the visibility over a post-mounted beacon. The sign is also intended to improve comprehension of its purpose, especially when the signal is dark. So similar to an RRFB, this device is actuated by a person wishing to cross the roadway. Until then, the PHB is dark. Once the button is pushed, a flashing yellow is displayed, followed by a steady yellow, using a yellow change interval based on the speed of traffic, like we talked about earlier, and then the steady red. And the red signal stays on in conjunction with the pedestrian walk signal display. Then during the don't walk pedestrian phase, the vehicular signal goes to a flashing red, like an always stop. And then, so drivers can proceed when the crosswalk is clear. Then it returns to the dark phase. There aren't too many of these in Kansas in use, but there are several locations in Lawrence that I know have them. Anybody have any in your cities that you want to share about? All right. Another pedestrian countermeasure is especially useful where the pedestrian has longer distances to travel to cross the roadway. By providing a median or pedestrian refuge island, the pedestrian only has to wait for a gap in one direction of traffic, then can wait in the median to complete their crossing until the other direction clears. This countermeasure can result in a 56% reduction in pedestrian crashes. So here's a median pedestrian refuge island near a roundabout. One thing I wanted to point out that there is space between the crossing and the roundabout itself for at least one vehicle to store. So the motorist first focuses on the pedestrian, and then after passing the crosswalk, then they can focus on the other vehicles in the roundabout. Of course, there's a storage area there for the pedestrian. And then here's a median of a two-way left turn lane that has a dedicated space for pedestrians to stop and store before completing their crossing. I'm assuming this is not a major intersection since they kind of blocked off the turn lanes here. Actually, it says no left turn lane there. But up here, there is a dedicated left turn lane. This one is more focused on the pedestrian crossing. Cool. So this is one of the cross-cutting countermeasures. A road safety audit considers all road users in a review of the roadway and documents recommendations in a formal report, or a semi-formal report at least, and can result in up to a 60% reduction in total crashes. Here's a closer look at the process. So first, a location is identified and a review team is selected. The team meets and reviews the location in the field. They then come together to discuss issues and make any recommendations. And a report is submitted to the roadway owner, and a formal response is requested. The final step, of course, is to incorporate the recommendations into construction or maintenance project. The Kansas LTAP has been leading RSA training focused on vulnerable road users, such as pedestrians and bicyclists, recently, but any roadway can benefit from a review. If you'd like more information on the VRU RSA training, please visit KDOT's multimodal website. And if you need to know about that, let me know. I can get you that link. So this countermeasure for enhanced delineation for horizontal curves can have many components. The one I have highlighted has the highest reduction in fatal and injury crashes at 60%, but I wouldn't necessarily recommend sequential dynamic chevrons as a first treatment. Other options listed are installing chevron signs themselves, or oversized chevrons, in-lane curve warning pavement markings, and fluorescent sheeting on curve signs. Even just installing retroreflective strips on the chevron posts is a very low-cost countermeasure that can really stand out, obviously, especially at night. Horizontal curves can also be improved by pavement friction management. This fact sheet shows up to a 48% reduction of injury crashes for horizontal curves, 20% reduction for total crashes at intersections, and up to a 63% reduction in injury crashes at ramps. So what are we talking about here? Finding ways to increase the friction at locations where vehicles are frequently turning, slowing, and stopping. So again, intersections, curves, or a combination such as a loop ramp. So here's an example. The first layer is thermosetting polymer resin binders to lock in place a layer of durable anti-abrasion and polish-resistant aggregate. Calcined bauxite is the aggregate shown to yield the best results. So Kansas has recently added at least 2 reduced left turn conflict intersections that I'm aware of in Kansas City and Goddard. I think both of these are signalized R-cuts, restricted crossing left U-turns. There's another displaced left turn intersection in Olathe, but that's a little bit different. Left turn movements are often part of intersection crashes. So finding ways to improve the safety of those movements is important. So here are two configurations covered by this proven safety countermeasure. As you can see in the R-cut, again, the restricted crossing U-turn, the side road traffic must turn right, and then make a U-turn to either make a right, continue their through movement, or make what would have been their left turn movement. In the R-cut, the main line traffic does make the U-turn at the intersection. This particular one shows stop signs, but the layout is the same if you have signals. MUT, the median U-turn configuration, allows side road traffic to make the through movement, but left turns are still made through that same U-turn movement. In this case, the main line also must use the median to make their U-turn to make their left turn. And so a lot of times extra pavement is provided over here for that movement, and then people can then just stay in that right lane because they're making, that's where they're going to. They would have been turning. So that was not a low-cost countermeasure, but this one is certainly closer to low cost. Longitudinal rumble strips and rumble stripes. Shoulder rumble strips can lead to up to a 51% reduction in run off the road, fatal and injury crashes on two-lane rural roads, and centerline rumble strips up to 64% or head-on fatal and injury crashes. So this roadway has both shoulder rumble strips and centerline rumble stripes. The rumble stripes are where the pavement marking is placed on top of the rumble. And this next slide is going to show that a little bit clearer. Again, any thoughts? Feel free to unmute or put comments in the chat. I don't see anything there, but if you have any comments on any of them, just let me know. So roundabouts. We're now up to an 82% reduction in fatal and injury crashes for a previously unsignalized intersection. 82%. Even starting with a signalized intersection and going to a roundabout reduces crashes by 78%. The reduction in conflict points is the key here. So here's a simple single lane roundabout. Hopefully you're pretty familiar with those. And here's a multi-lane roundabout. And I thought you might not be as familiar with those, so I'm going to leave this here for a little bit so you can picture how a vehicle would move through. And I'll walk through that. We're going to start with with someone in the right lane of a multi-lane roundabout. Again, first we're going to yield to any pedestrians in the crosswalk. Then we get to this point, we're going to yield to any traffic that's already in the roundabout. In this case, that red vehicle, we need to wait for them to clear. And if there's anybody else following them, then we can go ahead and make our right turn movement, or continue through making their through movement. I always say just follow the pavement markings. And once you're in there, you have the right of way, so you don't have to worry about traffic entering from the other road. And then you go on and make your movement. If you are in the left lane, again, yielding to the pedestrian first, then yielding to traffic in the roundabout. Again, following the pavement markings, you can either make that through movement, pretty straightforward, or you can make the left turn movement. I mean, technically, you could choose either lane. I tend to stick to the inside lane, just like if I was making a left turn at a regular intersection, stay there. Another option is to continue if you need to make a U-turn for whatever reason. And so that's another benefit of these. We'll talk about that a little bit later. But on all of these, again, as you go to exit, hopefully there is space there to store outside of the roundabout before you need to yield to any pedestrians that are crossing. So I think that's a benefit. You're not stuck out. You know, if the crosswalk was up here, you would be stuck out in the middle and kind of gum up the whole roundabout itself. So giving that extra storage space there helps you focus on the appropriate thing and be out of the lane of traffic. So now we're at the top reduction, and that comes from walkways. Walkways can be sidewalks, shared use path, or roadway shoulders. Adding sidewalks can add up to, or can reduce up to 89% of crashes involving pedestrians walking along roadways, and paved shoulders can reduce 71% of crashes. So here's a sidewalk, and here's a paved shoulder being used as a walkway. So again, this is intended to be a bit interactive. So if you have any comments or questions, feel free to jump in anytime. But I kind of thought there might not be a whole lot, so we have time to go through most of the rest of them just a little bit quicker. Again, here are the countermeasures and their categories. I'm going to go through the ones I haven't covered. I'm going to start at the top, but I'm going to skip speed safety cameras since they can't be used in Kansas, and variable speed limits because I don't know of any local agencies using variable speed limits. So appropriate speed limits for all road users. So this countermeasure is setting speed limits with all road users in mind, not just drivers. Two systems that are suggested are US Limits 2 and the National Cooperative Highway Research Program Report 960 on posted speed limit setting procedure and tool. These systems take into account things like the context, driveway density, and traffic volumes in addition to observed speeds. So Michelle is asking about the roundabout flyer, and for all of these, at the end, I'm going to give you a link to the website where you can find these. Really, as I will say at the end, if you just search for proven safety countermeasures, it's probably going to be the first thing that comes up. But I will give you that specific website at the end. And if you'd like me to mail it to you, I can certainly do that as well. So wider edge lines, it's considered wider when the width is increased from 4 inches to 6 inches. I know KDOT has gone to a 6-inch edge line as their standard. So that's just a standard thing for them. Benefit cost ratio, again, pretty high, 25-1. So again, that in this case, kind of like the safety edge, you're doing the work anyway. You're just adding adding more material. So that increase in material cost is not huge when you're talking about the work. And so that gives you the much higher benefit cost ratio than some of them if you're doing something just individually on its own. But in this case, it's just an addition to what you are already doing. The other benefit about these is about wider edge lines is it's a benefit for automated vehicles or those with lane keeping features. They can see those wider edge lines much better, much easier. So roadside design improvements at curves includes a variety of improvements, including an unobstructed clear zone, slope flattening, adding or widening shoulders, and roadside barriers such as cable, guardrail, or concrete barrier. I think when we think of improving clear zone or slope flattening, we imagine a fairly large project, especially if there's a lot of trees and brush along a roadway, or if you have limited right-of-way. But for this countermeasure, it's just focused on the curve area itself. So clearing or flattening the slope along the outside of a curve can provide safety benefits without too much effort. As you can see, obviously there's still a lot of trees and things in this area, but just this benefit just along the curve itself is what this countermeasure is focused on. Okay, I'm going to skip median barriers, and this is a simple one for signalized intersections that can lead to a 15% reduction in crashes at an intersection, just adding a retroreflective border. The simplest is just adding tape to an existing backplate, but you can also buy backplates with the retroreflective border already incorporated into it. They really stand out for a decent reduction in crashes. Okay, so corridor access management. That could be closing a driveway, but it could also be consolidating driveways or relocating them to the side road. It could also be limiting access to right in, right out. Here you can see one approach to that right in, right out by providing a median between two roundabouts. Really kind of forces that entrance to be right in, right out. So, for example, if you're coming this way and you wanted to make that left turn, all you need to do is go to the next roundabout and make that U-turn movement, kind of like we talked about with the roundabouts, and then a right in. Simple enough. Same thing if you're going to make that left turn out. You make the right turn instead, use the roundabout to make the left turn. Much safer. I believe this was used as part of the Hayes Roundabouts project. So dedicated left and right turn lanes at intersections are most beneficial on the main line, not so much on the side road. You may see a reference here to a positive offset. And I'm going to look at those a little bit closer so you know what we're talking about. So traditionally, the waiting area for a left turner is directly opposite. You know, this shows a median, but even if not, you understand that they're directly opposite each other. And when you do that, the opposing left turner can block through traffic in the adjacent lanes that the left turner may not see, and they go to make their turn and are struck by an oncoming vehicle. With a positive offset, the left turn lanes are separated from each other so that they're not blocking each other, and the left turner can see that approaching traffic much better and know when the gaps are available. Again, the systemic application of multiple low-cost countermeasures at stop-controlled intersections. Again, this is like some of the others. It can include a variety of countermeasures. But the overall average benefit cost ratio is 12-1. So let's look at some of the options based on each approach. I usually think about the side road approach, getting drivers to recognize the upcoming stop situation. This could include stop ahead signs on both the left and right side, making them larger, adding retroreflective sheeting to the posts, clearing vegetation. Looks to me like they need to clear a little bit more. Up here near the intersection, I don't even see the stop sign, but they do at least have the left side stop sign. They added a double arrow warning sign. I personally prefer it right in line with the approaching traffic, but sometimes there is an entrance or a driveway or something there, so they need to offset it. I can't really tell in this picture, but I recently saw an option that included red end of road markers on both sides of the double arrow warning sign. And that seemed like it would attract a lot of attention. You could also add flags or beacons to the signs, lots of options. Now let's go look at the main line. So again, I usually focus on the side road, but there are quite a few things that can be added to the main line or through approach as well that is not needing to stop. So things like advanced intersection warning signs could be right and left. These look oversized. You could add beacons, and advisory speed, supplemental street name signs, and retroreflective sheeting to the posts. This picture looks like there's some other signs as well. This one's probably a pedestrian or school sign of some sort. The fact sheet also includes or suggests enhanced pavement markings such as edge lines. I would suggest a no passing lines as well. If this were a 2-lane roadway, it looks like this is 4 lanes, but a lot of things you can do there to improve safety. So a leading pedestrian interval, abbreviated LPI, is generally 3 to 7 seconds of additional time at the beginning of the pedestrian phase to give pedestrians time to get started crossing so that they're farther into the intersection for better visibility by turning motorists. As long as your controller can handle it, and almost all should be able to do that, the only cost really is the short amount of time it would take to go out there and change the programming. So just brings that pedestrian out in front. And another pedestrian one is crosswalk visibility enhancements. Again, like the other enhancement countermeasures, there are several options. In this case, with up to a 42% reduction in pedestrian crashes. So here's a close-up. Here we have more pavement markings than just 2 transverse lines, which a lot of places just use the 2 lines. This one I think they call ladder configuration, but there's some other options on enhanced visibility pavement markings. They've got the pedestrian crossing signs. We have in-street signing and improved lighting. The lighting is in advance of the crosswalks, so the person is illuminated so that you see them, not just their silhouette. One other thing I was going to note here is that in Kansas, the state law is yield to pedestrians, not stop. So use the right one. I've seen stop in some cases, and that's really not what our state law says. So just use the right one. But I think they can be effective, just a matter of maintaining it out there. So we call this a road diet. but actually physically reducing the roadway width can be costly. So that's why I like the term roadway reconfiguration. We're really just remarking the roadway to better accommodate the traffic. So probably going to be going back and forth a couple times so you can see in this picture, the picture I'm going to show on the next page is this one, but I'm assuming the configuration was a 4-lane going to a 3-lane by adding that 2-way left turn lane and reducing the through lanes to 1 in each direction. Now you might think that's going to reduce the capacity. If you have left turning movements, say entrances and things along here, it really isn't going to reduce capacity much because in the original configuration, if someone is stopped to turn left, that lane, it can't be used anyway. And the other thing about this is if you have somebody stopped here, and especially if you have another left turner stopped, then we talked about the positive offset or the traditional at an intersection, kind of like the 2-way left turn lane, where you're opposite each other. In this case, the before configuration, it's really a negative. So not only is the vehicle not right in front of you, it's even to your left, which blocks that vehicle even more. So going from this configuration to this is much safer. In this case, it looks like they were also able to add bicycle lanes while still keeping parking lanes. To me, just the benefit of the left turn lanes is enough of a reason to do this. If you don't need the bicycle lanes themselves, you can provide a painted median, maybe making this a little bit wider so that a pedestrian might have a place to store, or you could do bulb outs at an intersection, again, to get those pedestrians farther out if they need to cross. If this is a pedestrian cross, it doesn't look like this particular intersection is intended for a pedestrian crossing, but there's just other uses that you can make of that additional pavement. Lighting's another countermeasure with pretty high safety benefits. It just wasn't enough for my top 10, but lighting, pretty straightforward. And finally, local road safety plans. That's what we call the county plans, or cities, a lot of times it might be called a safety action plan. Like from Safe Streets and Roads for All, for example, all basically the same thing. It's a plan to improve the safety, generally focused on low cost, risk-based systemic improvements. I would point out that the safety benefits here listed here come after implementation. Just having the plan is beneficial because it means you're thinking about safety, but taking action is the key. So the document of all the proven safety countermeasures is available here. highways.dot.gov/safety/proven safety countermeasures. I have this bookmarked for myself, but to be honest, I don't use the bookmark. I just type in proven safety countermeasures and it comes up because I have a lot of bookmarks and trying to find the one I want sometimes isn't the easiest. So again, just proven safety countermeasures. I'm going to give you one more opportunity here. If you have any questions or thoughts about any of these, if there's any of these that sound like something that you would like to incorporate into maintenance or construction projects that you have, it's going to make things safer.
Hi, Nelda. This is Carla.
Hi, Carla.
Hi. On your first slide about the traffic signal with the timing of the yellow light,
Uh-huh.
my question is, um, has there been a certain speed that this has been most effective with to change the yellow light in timing? Does that make sense what I'm asking? Is it like 30 mile an hour, 40 mile an hour, or to get that number of 36 to 50 reduction in red light running?
Well, I, I don't know. I'll say that to
Okay.
start. I can guess.
Okay.
Um, and I don't know that it's a particular speed, but it's just, a lot of places they use a particular, say, 4.5 seconds. I don't know what it is, but say 4.5 seconds for all of their yellow change intervals in their city. It's just kind of a
Okay.
standard
Uh-huh.
thing. And I think if you then look at individual intersections based on the speed of approaching traffic, and time them in that regard, um, you're probably more likely going to get that improvement. Now, obviously, it becomes more critical at higher speeds, because if you run a red light at 50 miles an hour, the crashes are going to be more severe than if you run a red light at 20 or 30. So
Right.
it, I the information that I have read doesn't say that. Maybe if you look into some of the reports that it references, you might get some more insight from that.
Okay. All right. Thank you.
Sure. Anyone else? I'm gonna quickly get back to the end. Wish there was a quick way to do that, but this is what I know. Um, Again, so you have that um, website. Um, our next roundabout is going to be on August 8th. Again, second Friday at 11. If you have a topic that you'd like to cover at either the August roundabout or future ones, feel free to contact me. My email is pretty simple, nelda.buckley@ku.edu.
Nelda, real quick, I had a quick one for you or for
Sure.
anyone else on the call here.
Yeah.
As more of these countermeasures are coming online, so to speak, and being implemented throughout Kansas, is Kansas seeing some of the same kinds of uh, reductions? I mean, all of these are just a lot of great countermeasures here. I'm just curious if anybody is, taking that on, doing kind of some after studies, if you will, or seeing if
Yeah.
they're finding the same kinds of safety benefits.
As far as I know, there has not, and Haley was on earlier. I don't know if she's still on. Doesn't look like it, but I'm not aware of anybody that actually has been tracking those in Kansas. I think it would be um, very interesting and a very worthwhile thing for Kansas um, to check on, to track. I know just in general, maybe not this year, but in general, our crashes were going down. Um, so
Yes, yeah.
um, so I think as these become more um, well known, hopefully that is at least contributing to the um, reduction in fatalities. But I am not aware of anybody that's actually been
Yeah.
tracking, and it's a lot
Okay.
of them are so um, low cost, incremental changes, even an agency may not track, when did we go out and reprogram our signals? Or sometimes it might just be at a particular intersection that we reprogrammed. And I'm just using that yellow change interval as an example. It doesn't feel like a huge improvement, but when you do a little bit here and a little bit here and a little bit here, it all kind of adds up. Same thing with, some of the curve improvements or whatever. It's really, certainly tracking it would be great, but I think figuring out specifically when all these improvements were made and tracking the before and after, great summer intern project, I guess.
Yeah, absolutely good information, and thanks for sharing all that great information on these countermeasures.
Yeah, and a lot of it I think is, a lot of them probably aren't new ideas, but hopefully it's just a reminder of, oh yeah, I kind of forgot that might be something that we could do, or oh, there's a location that I've been having some issues with. That probably is a good countermeasure that we could try at a particular location. So, again, thank you all for joining us, and hope you all have a great weekend.